Right now, inside every cell of your body, there's evidence that humanity almost disappeared forever. And scientists didn't find it in a fossil, or a ruin, or a burial site. They found it inside your DNA. When geneticists compare human DNA to that of chimpanzees, they find something strange. We're less diverse, far less. 2 chimpanzees from neighboring hillsides in Africa can carry more genetic variation between them than 2 humans from opposite sides of the planet. For a species of 8 billion, that shouldn't be possible, unless, at some point, there weren't 8 billion of us. Unless there were only a few thousand. Unless the entire human story once passed through a bottleneck, so narrow it very nearly didn't continue at all. Somewhere in Indonesia, 74,000 years ago, a mountain did something no volcano has done since. And when the ash finally settled, some scientists believe our species stood on the edge of extinction. By the end of this, you'll understand not just what happened, but what it reveals about how fragile and how astonishingly resilient the human story actually is. But first, we need to answer one question that scientists still can't fully agree on, because the real mystery wouldn't appear for another 74,000 years. Inside our DNA, volcanic ash and sulfur aerosols, once lofted high enough, can reflect sunlight back into space, and Toba injected so much material that some climate models suggest global temperatures may have dropped for years afterward. What researchers call a volcanic winter. Ice cores from Greenland show a distinct sulfate spike, matching Toba's timing, physical proof the eruption's fingerprint reached the poles. For early humans living in small, scattered populations across Africa and Asia, a prolonged cooling and disrupted growing seasons could have meant famine on a continental scale. Picture Sumatra as it was then. Dense forest, river valleys, ordinary life continuing exactly as it had for generations. Beneath it, a chamber of molten rock had been building pressure for tens of thousands of years, patient beyond human comprehension. When it finally broke, it didn't erupt so much as detonate. Imagine every mountain range in a small country collapsing inward, then hurled back into the sky as ash. That's the scale of material Toba threw into the atmosphere, enough to bury entire regions meters deep in debris. And yet the eruption itself wasn't what nearly ended us. What came after was. The blast reached the stratosphere, spreading a curtain of fine ash across the globe. Ash that's been found as far away as India and the seabed of the Arabian Sea, in layers geologists can still measure today. This wasn't a local disaster. It was planetary. In 1998, geneticist Stanley Ambrose proposed something audacious. That Toba didn't just change the climate, it nearly ended us. Comparing the unusually low genetic diversity in modern humans to what a catastrophic population crash would produce, he suggested our ancestors may have been reduced to as few as a few thousand breeding individuals scattered across an entire continent. Fewer people, potentially, than fill a single football stadium, carrying the entire future of a species forward on nothing but chance and endurance. For decades, this became one of the most compelling ideas in human evolution, that every language, every culture, every face on Earth descends from survivors of a near-extinction event. But that's not where the story stayed. Because archaeologists eventually found something that shouldn't have existed if the theory were true. At Pinnacle Point on the South African coast, digs revealed stone tools and continuous habitation stretching straight across the eruption's time frame. No gap, no sign of sudden collapse. If Toba had truly starved humanity to the edge of extinction, researchers argued, we should see abandonment, not continuity. That's where the extinction theory started to fall apart. Some scientists now suspect our genetic bottleneck may trace instead to something even earlier, the long, difficult migration out of Africa itself, when only small founding groups pushed into unfamiliar continents. In this view, Toba may have been a severe regional catastrophe, not a near global apocalypse. So, which is it? Researchers remain genuinely divided, and that disagreement is itself revealing. Because whichever explanation eventually wins, both point toward the same unsettling truth. Humanity's entire diversity of cultures and civilizations was built from an improbably small starting population. Genetically speaking, we're closer to a single extended family than any other widespread mammal on Earth. Some evolutionary psychologists argue that living in tiny, exposed groups may have reinforced instincts like trusting the familiar and staying wary of outsiders, patterns that, they suggest, can still shape human behavior today. This is where the human story becomes impossible to ignore. Somewhere in that era, individual people, not abstractions, not statistics, faced skies darkened by ash, harvests that failed, winters that wouldn't end. Some groups likely didn't survive at all. Others found refuge, coastal sites rich in shellfish, inland valleys with reliable water, pockets of stability scattered across a destabilized world. The fact that you exist today means that, somewhere in that chain, someone made a decision, took a risk, or simply got lucky. Generation after generation, unbroken, until it reached you. It's worth pausing on why this idea took hold in scientific culture the way it did. A single event nearly wiping out humanity has an irresistible narrative shape, a clear villain, a clean ex momis, a tidy explanation for a genuinely strange genetic pattern. That's exactly why it spread so quickly through documentaries and textbooks, often repeated as settled fact when it remains, more precisely, a compelling hypothesis still being tested, separating what the ice cores prove, what the genetics suggest, and what remains inference isn't a weakness in the science. It's exactly how the science is supposed to work. Zoom them out far enough, and Toba stops being just a volcano story. It becomes a case study in how close the entire human project has come to simply not happening. Every civilization, every invention, every idea ever written down depended on a population small enough that a single catastrophic winter could plausibly have ended it. And yet we're still here, not because survival was guaranteed, but because enough small groups, in enough scattered places, endured long enough to pass the thread forward. That's not just paleogenetics. That's the oldest form of resilience there is. So when you look at the genetic code shared by every person on Earth, remarkably uniform, oddly narrow for a species this large, you're not just looking at biology. That signature inside your DNA is a reminder of just how close humanity may have come to disappearing. It's the echo of a bottleneck, whichever exact moment caused it. It reveals that the human story was never inevitable. It was built quietly and improbably by ancestors who didn't know they were ancestors, who simply kept going through a darkened sky toward a future none of them could see, against odds that still make scientists argue that future survived. And today, you're living proof that it did.